My name is Julian Podgórski. I am a PhD student at the Institute of Geophysics of Polish Academy of Sciences. And today I'm going to tell you about volcanoes, about how I will start with a short recap, so to say, of how a volcano works. And later I'm going to tell you stories of different eruptions, of different historical volcanic eruptions, and what kinds of consequences did they have for human society. Let's start with a volcano. Yeah, it seems that this graphic is in Polish, but I guess you'll do. A volcano, according to definition, is a place on Earth where lava, pyroclastic materials, and gases are released from the depth of the Earth. So that's a definition. And on this diagram, you can see the mechanism of how it works. The brownish big part at the bottom is the Earth's mantle. It is solid in most of its body. But the warmth that's coming from the Earth's core, the red wavy arrows, that are the warmth that's going up, make it that parts of this mantle become more plastic, more elastic, and this causes convection and movement of this material upwards towards the crust. And the crust of the Earth is this topmost layer on which we are walking, and it is solid as well. It's not liquid, but between the crust, the bottom of the crust, and the solid part of mantle, there is the asthenosphere. It is a layer of mantle that is elastic. It's not liquid. It is still solid, but it's elastic, and this allows the tectonic plates of the crust to move. This plasticity is caused by reduced pressure. In the bottom of the Earth, the pressure from overlying rocks is much higher than above. So once some parcel of the mantle material is reaching as high up as the crust, the pressure is much lower and it can change its physical properties. And the same happens in magma chambers. Magma chambers are, so to say, holes in the crust. When rocks from the mantle enter those magma chambers, the pressure is so low because the layer of rock above it is even smaller than in asthenosphere. This pressure is so small that rocks become actually liquid only here in magma chambers. And this causes it to become magma, that is the liquid rock underground. This rock is accumulating with time. There's because of this convection and movement of the crust, the amount of magma in a chamber is rising. And together with magma, there are also gases from inside the Earth that are released from liquid rock. And together those things increase pressure in a chamber that when it's high enough, this pressure causes the whole content of it to erupt, to suddenly be thrown out through a hole in the crust. And that's what an eruption is. An eruption is when material from the depth of the Earth, like lava and gas and various solid materials like ash or volcanic bombs, is released onto the surface. The magma that's flowing on surface is not magma anymore; it becomes lava. So liquid rock on the surface of the Earth is known as lava, while the liquid rock underground is magma. And together with lava, we can have pyroclastic material that's being ejected from the volcano, and also large amounts of gases, which are often toxic. So an eruption is an interplay between the pressure and and the shape of the magma chamber. And now, when that we more or less understand how does a volcano work, we can move to our stories about volcanoes. We will start with Iceland. I dedicated this little slide to Iceland specifically, as it is an island in the north of Atlantic that is lying on top of the Atlantic Rift. The Atlantic Rift is a zone of rifting that's stretching through the whole of Atlantic Ocean, and this rift zone is causing very big volcanic and tectonic activity. So on the map on the right, you can see all those orange spots, orange and brownish spots, which indicate areas of rocks that were created because of relatively recent eruptions. And actually, the whole of Iceland is built of volcanic rocks, but most of it is so old that there is no volcanic activity left anymore. But in this belt in the middle of the island, the volcanoes are still active, and many volcanic phenomena can be observed. And we could call this island a volcanic zone because it has many different kinds of volcanoes. And we'll now move to particular eruptions. I have ordered them in some kind of sequence from the least destructive to the most destructive. So we will start with eruptions that are not really destructive. Surtsey is an example. First, an example from Iceland. It's a mechanism, a kind of case of a volcano that's actually creating new land instead of destroying things as we're used to. Between 1963 and 1967, an eruption of underwater volcano just south of Iceland has begun. The volcano was erupting for some time by then, but as it was located underwater, most of the lava was just spread around on the sea bottom. But after some time, the mountain that is the volcano, the cone, grew so high that the rocks and pyroclastic materials reached above the water level and started creating an actual new island. I will now show you a movie from these events. There is a big advantage to the recent events, to speaking about recent events, because we can have actual video footage of them. So that's how it looked in 1960s when Surtsey was erupting. You can see that it is actually quite violent, but no one is living there, so there's no destruction involved. And all of this is happening just above the sea level, as you will see in a short while. So all this lava that's being ejected is solidifying because of contact with relatively cold water and air, and building a new island, as you can see. It has a big crater in the middle that's spewing out all the lava. It's actually quite a spectacular sight to watch, how a new island is formed, even if it's quite a small island. You can also see a large amount of gas and steam that's actually quite toxic. And the surface of such freshly formed volcanic island, as you can see, it's rather unpleasant. It rather resembles a moon surface than something that we would associate with Earth. So as you can see, there was a lot of lava and smoke involved in this eruption that gave us a brand new island in the Atlantic. And these two images on the bottom are showing us what is going to happen to this island. The left photo is a contemporary aerial shot of Surtsey. That's how it looks nowadays. You can see that it's much more green. There are some plants, some mosses that have managed to get to the island from Iceland. There are also really a lot of birds that want to live there. The many sea birds that live close to the sea like such islands to build colonies to nest there. But in the long term, the island is going to look more like a nearby volcanic island, as which you can see on the right image. As you can see, its walls are very, very steep. They are very steep cliffs, and the rock is very black. And that's what's going to happen. With time, the sea is going to erode all the loose pyroclastic material that is accumulated on the island, and the only thing that will be left of this island is the core made of solidified lava. So this island, the one you can see on the left, is partially made of solid rock lava, but also partially of things like dust and ash and stones that were brought out of volcano and will be with time removed by the sea. The second Icelandic case I will tell you about is Holuhraun. It's actually a very recent one. It happened in 2014 and 2015. For several months in a fissure, gases and lava was being ejected from a fissure in the center of Iceland, quite close to the middle of the island. Since no one is really living there there are no big villages or cities in the middle of Iceland, the eruption did not cause any actual destruction. But it was very, very spectacular, and it was something that we could call a textbook example of an effusive eruption. An effusive eruption is the one kind of eruption that do not give away pyroclastic material. So you only get lava and gas. No ash, no stones, no dust. And again, I can show you a movie that has been taken there by a drone. As it happened really, really recently, people were able to go there with use of drones and fly unmanned vehicles around this boiling sort of lake of lava, which is going to look quite impressive and quite dangerous, but actually it's not that much. It was, though, forbidden to go to the area for people who didn't have authorization, because the concentration of toxic gas around this place was so high that it was actually dangerous to go there without proper gear or for a longer time. But as you can see, some movie makers were granted permission to film how the Bardarbunga eruption is unfolding. You can see there's a river of lava with some boiling lava. It's all quite beautiful actually and impressive, but you can see that there is no pillars of smoke. There are no ash that's being ejected. The air is quite clean aside of the steam and gas that's being released from this lava river. The drones and the machines that were operating in this area were actually quite expendable. Not all of them survived the high temperature. So right above this lava lake, the temperature is so huge that it's dangerous for a drone. It can just melt or break because it's so hot. The result of this eruption was a fresh lava field, so a sort of field of fresh rocks that looks like on the image here on the bottom. Today you can see that it's a kind of riverbed with two ridges that border it, and it's in the middle is where the lava flow was going. Once the eruption was gone, everything cooled down, solidified, and created this bed of fresh black rock. The next Icelandic eruption is another one you might have heard about. In 2010, the Volcano Eyjafjallajökull has been erupting for some time, and the result of it was that a huge amount of ash and material has been ejected to the atmosphere, which caused great problems for aviation. Actually, in almost whole of Europe, it was forbidden to fly because it was dangerous to use airplanes in this ash saturated air. And this eruption was particularly bad because Eyjafjallajökull was located underneath a glacier. And this eruption of Eyjafjallajökull was a great example of explosive eruption as contrasted with effusive. Explosive eruption is, as the name suggests, connected to huge explosions. As you could see before, there weren't really much explosions on the previous image. It was just a river of lava. And in case of Eyjafjallajökull, we had big explosions. And the scale of this explosion is dependent on the amount of gas in magma chamber, as I have mentioned on the first or second slide. And as this volcano was located underneath a glacier, the water from melted ice got into the magma chamber, into the volcano. It melted. It created steam that increased pressure and made the explosions much more violent and energetic. Once again, we can watch a movie of an explosive eruption of Eyjafjallajökull, as again we're lucky. What am I sharing? Maybe I can just share it correctly. Opera Internet Browser. Good. That's how it looked in 2010 when Eyjafjallajökull was erupting. As you can see, there's actually now this one is actually a big scale eruption. The pillar of smoke reached several kilometers up into the air. The destruction caused by the glacier again was not really very big. The main problem were sudden floods that were caused by melted ice that melted into water and flew downwards to the rivers, destroying bridges and some little farms. There was also a little problem on Iceland in the area of the volcano because not all the ash, but quite a big amount of this ash that was ejected up into the atmosphere fell down onto the surrounding areas, and it caused that houses and fields and cars were covered by a quite thick layer of black ash that had to be cleaned up after the eruption. But that's a classic case of explosive eruption made worse by the steam from melted ice. What is interesting about this particular case again is that Eyjafjallajökull is located quite close to a much bigger volcano that's known as Katla. And Katla, in historical times, since 930, when first people settled in Iceland, it was erupting more or less every 50 years. And since 1918, so that is for 100 years now, it had not seen any big eruption. And nowadays, geologists are sometimes worried that it's maybe time for Katla's eruption, which is going to be much more violent and energetic than Eyjafjallajökull. And you can see on the map on the left how big area of the northern hemisphere was affected by the ash cloud. The last case from Iceland that I'm going to tell you about is Eldfell, and this time we're going to talk about actual destruction. In 1973, a stratovolcano, Eldfell, on a little island on Vestmannaeyjar, south of Iceland, has suddenly erupted, and the case is interesting because at the bottom, at the feet of this mountain, lies a little town, Heimaey. That is a fishing town of Iceland, one of the fishing towns of Iceland. Suddenly, the people had to be evacuated, and all 5,000 of inhabitants had to be evacuated really quickly. This actually succeeded, so no one died because of this eruption, as they could be evacuated to Iceland on boats and airplanes and helicopters. But 1/5 of the town was destroyed either by the advancing flow of lava, which just crushed houses and buildings, or by the thick layer of ash and stones and material that covered those buildings. The Eldfell eruption is a very classical case of strombolian eruption, whose main feature is that it is, so to say, cyclic. The eruption is not continuous, it rather works in single pulses that eject lava and material and gas every several minutes. This is very slightly explosive. The explosions aren't as huge and ground-shattering as we could see in the previous movie, but still they are explosive and happen every several minutes. Eldfell is also a typical volcano as we imagine it. When we say volcano, we imagine a quite symmetrical cone, and that's how Eldfell is looking like, and that's a stratovolcano. Stratovolcano takes its name from the word strata. I think it comes from Latin or Greek, and it means layers. So stratovolcanoes, those cones, are built of many, many layers of material that has been accumulated in subsequent eruptions. So every time an eruption of a stratovolcano happens, the lava is flowing downwards on the slopes, and some ash accumulates and builds the cone even wider and higher. If a geologist would drill into such a stratovolcano, they would see layers of material, of rocks, of volcanic rocks. That's why it's called stratovolcano. Nowadays, the Heima A is again inhabited. People return to those houses that were not demolished and rebuild some of them. But some parts of the town remained covered by ash and stones, and they actually managed to build a little museum of the eruption where we can see how a house that's covered in ash actually looks like. And you might have heard about a similar story of a city covered by ash, the story of Pompeii, which is our next case. We're moving away from Iceland now if we want to have each next eruption more destructive. The Pompeii is a similar story as Heima. In 79-year Christian era, so a bit less than 2,000 years ago, a sudden eruption of Vesuvius volcano in Italy covered several Roman towns in ash, in pyroclastic material and ash, but mainly ash. And it happened very, very suddenly. No one in the area was prepared for such an eruption. So it actually happened suddenly, and instead of destroying, some of that was destroyed, but instead of completely destroying the cities, they were covered in thick ash that preserved the ancient Roman towns up until the current era. In the 18th century, these towns were actually uncovered. People realized that under the thick layer of ash there are ancient towns, and the archaeological exploration is happening up until today. As you can see on the right picture, the Herculanum, an ancient city that was uncovered from the ashes, looks like that. We can see exactly how a city of ancient Rome looked like. And if you can see that this town is located in a hole, so to say, like there's a thick, tall wall of rock or sand. So this thick wall of rock and sand is this ash bed that has covered the city. We have to admit that many people died during this eruption, so it's not as innocent as Iceland anymore. And the Pompeii eruption, this Vesuvius eruption from 1799 CE, is an example of Pillian eruption. A Pillian eruption is a very strong and very violent, very explosive kind of eruption. whose whose characteristic feature is a pillar of ash that reaches several kilometers up into the atmosphere. The ash is falling onto the surrounding areas just like in case of stratovolcanic eruption, but there's much more ash and much more material than in Eyjafjallajökull eruption, so it can cover greater area in much thicker layer. The name Pillion eruption comes from an ancient historian, chronicler Pliny, who has described the Vesuvius eruption. And here on the left picture you can see how it could have looked like in the ancient times. That's a photograph of Vesuvius eruption done in 1944, I think by some soldiers that were dispatched there during the Second World War, and that's when the Vesuvius eruption happened, and they could take the photograph of what the ancient Romans could have seen when Vesuvius erupted. So we have seen that the volcano can destroy several cities, but can it destroy anything more? Of course, yes. And again, we'll be speaking about ancient times, even more ancient than Pompeii. In 1600 years before our current era, so 3600 years ago, a lot of time ago, there was a civilization known as Minoan civilization in the area of Mediterranean Sea, close to Greece and the Crete island. And it was an insular civilization that was spread around several islands in the Aegean Sea. And again, suddenly, a huge eruption happened of the Santorini mountain. Santorini mountain is located on the island of Thera, close to Crete. And you can see this island on the left picture. You can see that it's roughly round, its shape is roughly round with a hole in the middle, and this hole in the middle is the trace of the eruption. So the volcanic eruption was so massive and so huge that it actually destroyed an island. This obviously didn't go without effect on the Minoan civilization. So first, the eruption has destroyed the palaces and towns that were built on Thera Island. Then a great earthquake has shaken the Mediterranean area, again bringing destruction to towns and cities on the coasts. And in the end, the great amount of ash and smoke has been ejected into the atmosphere, and this time it was so much, the amount was so big, and it went so far up into the atmosphere that the pillar of smoke has actually altered the climate. Very big eruptions, very big volcanic eruptions have the potential to change the climate of the Earth, sometimes locally, sometimes not, and cause cooling, as the big amount of ash and aerosol block the sunlight. They form kind of artificial clouds that reflect the sunlight and block it and prevent it from reaching the ground. So after the eruption, the climate became cooler, which caused an agricultural crisis and was another factor to the actual downfall of the Minoan civilization, which was first destroyed physically by the eruption and then slowly had to cope with famines caused by cooling of the climate. So that was an eruption that affected civilization at the local scale. And to move even higher up, to crank up the scale of destruction even more, we can speak about an eruption that has affected civilization almost worldwide. In 1815, so not that much time ago, 200 years ago, the Tambora volcano in Indonesia has erupted. It was the biggest eruption that was ever observed in history that we know of. There could have been bigger eruptions, of course, but we didn't record them in our historical times. It was the greatest eruption in history, and it caused a volcanic winter in almost the whole of northern hemisphere. The year 1816 and I think 1817 too were known in Europe and the USA as the year without summer, because the climate was so cool that the snow persisted up until June in the USA, and in Europe it was so cold that again the agriculture did not work well. There were really bad crops in Europe, which caused unfortunately a famine and continent-wide societal problems like famines, like epidemics, and maybe even some local riots and that kind of problems. What happened then was that eruption that was so huge that it destroyed a mountain produced an ash cloud that again got very up into the atmosphere and traveled all around the northern hemisphere. This kind of eruption is known as ultrapillion. It's very similar in its mechanism to a pillion eruption, so it's a massive explosion with a massive pillar of ash, but it's much stronger, and its consequences are not local but global. On the left picture you can see how Mount Tambora looks today. It's a huge massive caldera, and it's already impressive by itself, but it's good to know that before the eruption before 1815 the mountain was around 1.5 kilometers taller. The eruption was great enough to simply blow up half of the mountain and turn it into ash and smoke and stones that went into the atmosphere and down onto the local population, which unfortunately was not really prepared for so huge a catastrophe, and a great many people again has died in Indonesia during this eruption. Aside of these civilizational problems like famines and crops problems, the great amount of ash actually changed the color of the sky. We can see on the painting on the right picture at the bottom of the slide that was painted in England by a painter Turner. The painting Chichester Canal shows us the yellow sky. The sky is yellow on this picture, and it's not some artistic vision of the painter. It's actually how it could have looked like in England in 1815 and 16, because the ash and the particles in the air changed the color of the sunlight that was passing through it. So for some time after the big eruption, even in Europe, even in America, the sunsets had a very different color than they usually have. So that was the biggest eruption we have seen in history. Can we think of something even bigger and even more destructive? Well, actually, yes. Yellowstone, maybe you have heard about a supervolcano underneath the Yellowstone National Park in the United States. The supervolcano is, as the name suggests, a very big volcano. A supervolcanic eruption is defined as the one that has at least 10 times as much material released as ultrapillion. So Tambora was ultrapillion, it altered the climate on half a planet for 3 years, and supervolcano, if it was ever to erupt, would cause 10 times as much problems. So the climate would be much more affected than just a year without summer, and for much longer time than 2 or 3 years. Luckily, in historical times, the Yellowstone has never erupted, and any supervolcano has not erupted. We would have known it, certainly. But it's good to realize the scale of the supervolcanic eruption that has happened in geological history. And the map on the left shows us with those reddish-brown triangles how big areas of the United States were covered by ash in previous Yellowstone eruptions. You can see it's a bed of ash on the continental scale. Half of continent covered by ash. It's quite an impressive achievement. The caldera of the volcano is 70 kilometers by 30 kilometers, so it's certainly bigger even than Tambora or Santorini. And what is maybe a little bit unsettling is the thing that I have mentioned with with the example of Katla, the Icelandic volcano that was supposed to erupt every 50 years. So Yellowstone volcano, the geologists who are working with it has dated the two previous eruptions of Yellowstone to 1.2 million years ago and 640 million years ago, 1,000 years ago. So it's like way back into the history. There weren't actual history by then. But we can see that there is an interval of circa 600,000 years. And if this is true, if the hypothesis that Yellowstone is erupting with every 600,000 years, it would mean that we should be more or less prepared for an eruption in quite a short time. Obviously, it's geological scale, so short time in this case may mean 3,000 years. If it erupts in 3,000 years, it still doesn't break the cycle, so to say. And as for now, the geologists say it's quite calm, so we shouldn't expect it during next few years. But still, there is a concern about Yellowstone. And but before it happens, before any bad things come from it, we can admire the good things that come from massive magma chamber beneath Yellowstone Plateau, and that is the Great Prismatic Lake. That's quite famous sight from America and from Yellowstone. Its colors are caused by different kinds of microorganisms that live in the lake, and the closer they are to the bottom, to the center, the warmer it actually is, and the amount of different chemicals from the earth is different, causing different colors to bloom in the lake on the rocks. Thank you for attention. If you have any questions about volcanoes and explosions and eruptions, you can ask them now.